Hi guys, this is Miss Smith. I am showing you this wonderful presentation for 3.3 fossil succession and uniformitarianism. All right, I'm going to be asking some questions as we go through, so make sure you're looking. Today's objective, explaining the principle of funnel succession and how they relate to Nicholas Steno's principles of superposition. We're also going to talk about William Smith, and we are also going to talk a little bit about uniformitarianism and the concept that the processes in the past happen in the future. So, we're going to talk about James Hutton and Charles Lyell as well. Coming back to this essential question at the end, how has the rock cycle helped us learn about the history of the Earth? So let's review a little bit of our law of superposition. As you can see, oldest on bottom, youngest on top, position. Law of original horizontality, they will stay horizontal unless a force is acting upon it. This one is pushing it up, so you can see it's slanted. Lateral continuity, continuing until it ran into an obstacle. See how it continued onto the other side. All right. So now we're going to talk about relative dating. This is telling how old something is, comparing it to other ones. Not exact. So if I look at the bread on my table, I can tell that it roughly is a week old. Okay, it's been sitting there. Rock layers are just like that, a rough estimate. Okay, I could say that Jeffrey is 2.5 years old, or I can say that he is almost 3, or anything of that nature, instead of being 33 months old. So relative is comparing something to one another, okay? Not exact. So they're going to compare the rock layers from one to another in the same location. So remember back to our discussion that we had about Steno's principle. Our youngest on top, bottom is our oldest. Well, that continues to follow through as we talk about our funnel succession law and applying Steno's superposition law. Okay, so fossils are the same way. The youngest fossils are going to be up top. The older fossils are going to be on the bottom, just like our superposition. Okay, dragonfly towards the bottom, dinosaur is more complex. So if you take a look, our fossils that are further down in the different layers are going to be a little bit less complex. As we move our way up, they're going to get more and more complex as it goes through. Okay? So, funnel succession. Okay? Growing more complex as you move up in the layers. So, taking a look. A dragonfly isn't as complex as what a dinosaur is. That makes a big difference. Okay? So, groups of organisms have followed or succeeded another one through Earth's history. Okay?
Down, Mama.
So, if they get more complex as they go up, what happens if they are in the same layer? I'm going to have a question to answer. And when you come back, I will discuss. Okay? What they are. So, they would be of the same complexity if they are in the same layer. All right. So, William Smith, no relation, was one of the first people to look at this, getting more complex as they go up through these layers. And it's a help to come up with the relative age, okay, of sedimentary rocks. Well, this one's younger, this one's older, okay? He found that certain rock layers were very, 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 very far apart, and they still had the same rocks, which was pretty cool, or the same fossils, okay? And this fossil correlation means that over in Asia, over in Africa, that same time period is going to have the same fossils as the ones that we have here in the United States, down in. So we can correlate, we relate to that. So, principle of fossil correlation. The principle states that rock layers with the same unique grouping are the same geologic age. These are called index fossils. Oops, I get too excited and I click. These index fossils are pretty cool because they only were around for a particular amount of time. We have the same fossils here as we would in Asia or Europe or Africa. So it can help us to date the time frame. And you can see that from the picture, certain index fossils occurred at the most or at certain times. So you can see that this fossil right here is from a more complex organism than our one that's here on the bottom. This is a younger fossil compared to our older fossils. Okay? Less complex, more complex. Older, younger fossil. Okay? So, stratigraphy. Charles Lyell, good old Scotsman, studied to be a lawyer but became a geologist. So he decided to work and complete a column of layers that would help us to do a little bit of a time frame. So you can see this beautiful time frame as we work in there. Okay. I do have a video for you, which I will send you the link in a moment so that you can view, and a couple questions so that you can take a look. That'll help us with our different layers. I am also going to have you guys match up a few things so that you can see what we have. And we're going to come back to our essential question. How does the rock cycle help us learn about the history of Earth? Well, rocks changing, rocks going through that compression and cementation are going to help us to figure out and entrap those fossils. Okay? I do have a wonderful brain pop video as well for you. You do not have a graded checkpoint, but please make sure you have your study guide, your common assessment, your 3.02 from yesterday completed, your async day assignment from last time completed. Those are all important things that we need to make sure to do. All right. I hope you guys have a good day. Review, review, review.